Welcome to Biology My Passion. I am Soumya Harikrishna. We are going to start the chapter Carbon and its Compounds. It is a very important chapter in class 10. You have to learn a lot in this chapter. In this chapter, we are dealing with one major element, that is carbon. Carbon is very significant in our life, and also carbon is very important for us whether it is in its elemental form or it is in compound form. The earth crust contains carbon 0.02% and it is a non-metal and poor conductor of electricity. The carbon has an atomic number 6. So carbon is present in many living organisms as well. There are compounds which are present or extracted only from living organisms like plants and animals. Such compounds are called organic compounds. For example, sugars, fats, oils, proteins, vitamins, urea, all these compounds are present in living organisms. So these are all examples of organic compounds. And the interesting fact is that almost all these compounds contain carbon as one of its major ingredients. The branch of chemistry studying about these organic compounds is called organic chemistry. In class 10, it is just an introduction to organic chemistry. If you opt for science in 11th and 12th, you will learn more chapters in organic chemistry. Let's come back to our carbon. Carbon has got atomic number 6. 6 atomic number means what? Number of protons is 6. If number of protons is 6, what is the number of electrons? Again 6. Now, if you write the electronic configuration based on the atomic number, we can see that it is 2, 4. That is, K shell can have maximum 2 electrons. The other 4 will go to the L shell, right? So, whatever is coming in the outermost shell is called the valence electron. Here, the valence electron is 4. But we know that every atom is trying to get noble gas configuration. Here, to make it 8, it needs to have 8 electrons in the outermost shell. How many are here? 4 are here. It can either give 4 electrons or it can take 4 electrons. Usually we see elements which some elements give the electrons and certain other elements receive them. For example, in the previous chapter we learned about metals and non-metals. You know, the outermost valence electrons in metals are 1, 2 or 3. So they have a tendency to release or donate electrons. Whereas non-metals have outermost valency like 7, 6 or 5. Instead of giving, they receive the electrons. So if a metal is giving 1 electron, it can be taken by a non-metal. So this will gain positive charge, this will gain negative charge. Same way 2 electrons can be received by this, whereas the same way here also 3 if given, an element with a 5 outermost electron can take it. So this is a kind of give and take relationship, and in this case ions are forming, that is positively charged cations and negatively charged anions are forming here. So these compounds are called ionic compounds because ions are forming in this. And we learned about the characteristic of ionic compounds in the previous chapter. But when it comes to carbon, here carbon is neither giving 4 nor taking 4. How can carbon manage its outermost noble gas configuration? Or before going to that, let's see why carbon is not interested in giving or taking electrons. If you see a carbon atom, this is the nucleus with the 6 protons. This is K shell with the 2 electrons, and this is L shell with the 4 electrons. Okay, so valence electrons are 4 in number. If the carbon is giving out 4 electrons to get the noble gas configuration, then what happens? This will become 4 plus charge. It gains 4 plus charge. So the number of electrons is only 2, whereas protons is 6. So it is difficult for a carbon atom with the nucleus 6 plus to release 4 electrons because it requires a lot of energy. So removing 4 electrons in the outermost shell, leaving behind a 6 proton containing nucleus and only 2 electron containing orbitals is very difficult or highly energy requiring process. Now let us look at the other possibility. Why can't carbon take 4? If it takes 4, it will become 4 minus anion. So we know this will have 4 more electrons in the outermost shell. Now noble gas configuration is satisfied. But the problem here is it is difficult for the nucleus with the 6 protons to hold on to 10 electrons because there is an imbalance. Only 6 plus in the center but 10 minus are there around it. So it is difficult for the nucleus to hold on to it. So in such a situation, what can carbon do? Carbon, instead of giving or taking, share the electrons with the other carbon atoms or with the elements of other atoms. It need not be always carbon, maybe with the other atoms as well. It is not only carbon that is sharing like this, there are many molecules are sharing their electrons in order to achieve a noble gas configuration. In such a situation, these atoms are sharing the electrons from only the outermost shell and both of them can achieve a noble gas configuration. A bond formed as a result is called a covalent bond. The simplest molecule formed by a covalent bonding is hydrogen. So we know that hydrogen has atomic number 1. That means it has one positive charge and one negative charge. So if you represent this, here we are writing the symbol of hydrogen and we are representing only the outermost electron. According to Lewis notation, we can use a cross or a dot to represent electron because this was named after a scientist called G.N. Lewis who introduced this method, and this is also called a Lewis structure. So what we are going to draw is Lewis structure. So we are showing only the valence electron. Here hydrogen has one valence electron. There is another hydrogen with a one valence electron. Now these both can be shared. This hydrogen will be taking this also. So now it has got 2 electrons. The same way this also will be taking from this. So this also has got 2 electrons. So a pair of electrons is shared. So the pair of electrons represent one bond. So we can write it as H bond H. This is called a single bond. A single line represents a single bond and that line represents a sharing of a pair of electrons. In this case, we can see that both are getting shared between the outermost shell of 2 hydrogen atoms. It has only one shell, A shell, but now both are attaining 2. The next element is helium. The helium has got 2 as the atomic number, but it's a K shell only possible, so that is filled. This is the noble gas configuration. As far as hydrogen is concerned, the nearest noble gas configuration is 2. It has attained that. So now carbon is forming covalent bond to form the single bond H, or we can write it as H2, which is a molecule of carbon. The same way we can try out other molecules. For example, we will try now oxygen. So the atomic number of oxygen is 8. So we can write 2, 6. So here we are showing only the outermost electron in the form of dot or cross according to Lewis structure. So here we can mark it. How many more required? 2. So we can mark like 1, 2, 3, 4, 5, 6. These 2 will be shared. The same way another oxygen molecule is here. So this one can take this also. So it becomes 8. This one also can share this 8. So how many pairs of electrons are shared here? 2 pairs of electrons are shared here. So we can write it as O double bond O. Okay, so as a result we get an oxygen molecule. Let's look at the case of nitrogen, atomic number 7. So outermost orbital, so 2, 5. So it needs 3 more. So I am writing 3 here and 1 or 2, or you can write both, it's up to you. So here also I am writing this side. So sharing is easy. This nitrogen will take 3 more from here, making it total of 8. This will also take from here, making it a total of 8. So the shared ones will come in this overlapped region. So how many pairs of electrons are shared here? These are N, triple bond N, and this is N2 molecule. So here covalent bonds can be of different types: single bond, double bond or triple bond. But in all these cases we found both the atoms are the same kind. Oxygen is sharing with another oxygen, hydrogen is sharing with another hydrogen, nitrogen is sharing with another nitrogen. Such compounds are called homoatomic molecules because their atoms are similar in a molecule. Now we will look at the formation of certain covalent bonds between 2 different atoms. They are called heteroatomic atoms. So first one is carbon. So we know carbon has 6 as the value, 2, 4, whereas each oxygen has got how many? 8 each, that means 2, 6. So oxygen needs 2, carbon is ready to give 4. But one oxygen needs only 2. So it can be shared between 2 oxygen atoms. So if I draw carbon like this, okay, outermost electrons, 4 valence electrons. I am drawing oxygen here, but I am giving dot to oxygen. Why? Because it is another atom, right? I can use into also to avoid confusion. One I am using dot, one I am using dot into. So here this oxygen will take from here. So 6 plus 2, 8 it got. This oxygen also takes from carbon. 6 plus 2, 8 it got. Now carbon has 4. Carbon will take from 2 from this oxygen, 2 from this oxygen. So carbon also getting how many? 8. So 2 pairs of electrons are shared. So carbon has now the molecule carbon dioxide. Now if you look at methane, carbon has carbon has 4 valence electrons. Hydrogen also needs 1. So 4 hydrogen can pair with carbon. So this hydrogen is satisfied, this hydrogen is satisfied, this one is satisfied, this one is satisfied. Now carbon can take all from them. So this sharing forms 4 single bonds, right? C, H, H, H. So total this makes CH4 molecule, which is nothing but methane. This is an important compound in biogas. Next let us see water. Water, oxygen, okay. How many hydrogen are there? 2 hydrogen, because hydrogen needs only 1, but oxygen is ready to, oxygen has needs 2 more. So how to share? Here I am drawing 1 this side, 4, 6. So this hydrogen will take 1, this hydrogen will take 1, and this 4, 2, 4, 6 and 8. So total 8. So H2O, a pair of electrons are shared. Last hydrochloric acid we will see, HCl. Hydrogen has got 1 in the outermost shell. Chlorine has got 1, 2, 3, 4, 5, 6, 7. So hydrogen will take 1 from chlorine, sorry not carbon, chlorine, and chlorine will also take 1 from here. So both of them are happy, HCl. So these are the heteroatomic compounds formed by covalent bonding. Let's now see the characteristics of covalent compounds. Covalent compounds contain only molecules. There are no ions forming here because it's only by sharing the electrons, not by giving or taking. Then next is it may exist as solid, liquid or gas. We saw diamond is a form of carbon and it is in solid form, whereas water is in liquid form. Carbon dioxide or methane are in gaseous form. Then it can exist in crystalline structure or non-crystalline structure. They are usually insoluble in water or in polar solvents, because if you dissolve it in water, they don't form ions in that, in aqueous condition. So they are insoluble. But if you use non-polar solvents like a benzene, carbon tetrachloride or acetone, you can see they are dissolving. And basically covalent compounds are poor conductors of electricity because they don't have ions, and also they have low melting and boiling points. We are going to study about allotropes of carbon. Allotropy is the property of some elements to exist in 2 or more different forms. So you must be thinking, okay, hydrogen can exist with oxygen as water, or as hydrogen peroxide, or it can exist with a carbon to form methane. No, it's not like that. That same element or the atoms of the same element has to exist in different forms without combining with anything. Understood? So here each different forms of that particular element will have different physical properties because their combination or the structure is different, but they have same chemical property because ultimately they are all made up of the same element. In case of carbon, if you take, it has got 2 very common allotropes. One is diamond and the other one is graphite. If you look at diamond, it is a structure which is formed by the sharing of 4 valencies of carbon with the 4 other carbon atoms. That means carbon has 4 valencies, right? All the 4 valencies are satisfied by other 4 carbon atoms. These carbon also have got other 4 carbon atoms. So every single carbon in a diamond is bonded, or covalent bonding is formed with the other 4. So suppose if you consider these 4 as the 4 arms of a carbon, all 4 arms are occupied. They are all holding another carbon atom. in this case, this is giving a three-dimensional shape which will result in a crystalline shape with the 8 faces, that is octahedral, and that is why it is very shiny in appearance because of these faces and the refraction of the light through these faces. It's a transparent structure. Okay. This three-dimensional structure of diamond is very strong. Because of this, diamond is the hardest substance in nature. If you want to take one carbon out of a diamond, imagine you have to break 4 covalent bonds. It is very difficult. That's why it is becoming the strongest structure because of this regularity and symmetry. And it is a very poor conductor of electricity because no electron is free. Every side it is bonded with another carbon atom. But what is there? Ultimately only carbon is there. Diamond has got many uses. One, it is a very widely used as a jewelry because of its sparkling or shining crystalline structure. It is also used for cutting glasses because of its hard nature. Drilling rocks also we use diamond. Diamond is used as a tool for doing cataract surgery, and it's also used in high precision thermometer. But diamond is a poor conductor of electricity. If reason is asked, they do not have any free electrons or ions to conduct electricity. If you come to the second allotrope of carbon, that is graphite, it has exactly opposite properties like that of diamond. Because diamond is very transparent and sparkling, whereas graphite is black in color. And diamond is the hardest substance, where graphite is very smooth and slippery. Diamond cannot conduct electricity, whereas this can conduct electricity. The reason is, we saw in carbon, each carbon atom is bonded with the 4 other carbon atoms through covalent bonds. But here, each carbon is only bonded with the 3 other carbons, so 1 electron is left out. So everywhere 1 electron is available for conducting electricity, that free electrons are available. So it is called a good conductor of electricity. And these carbon combining with the 3 other, that each one combining with the 3 other, that is in a single plane. So it forms a hexagonal structure and laterally, so that another structure can form over it, another structure can form over it. And these different layers have very weak force of attraction between them. That's a van der Waals force of attraction. As a result, each one can slide over the other, that is making graphite very slippery. As a result, we can use it as lubricant. Other uses are in pencil lead. When we are using pencil, what we are writing with is nothing but graphite. You must have seen some experiments where we sharpen both sides of the pencil to expose the lead, and if you connect it with a circuit with a battery and a bulb, you can see the bulb is glowing because the lead can conduct electricity. The conductivity is due to that free electron, and the lubrication property is due to that weak force between the different layers. And another uses, sometimes it is used for making electrodes. The third allotrope of carbon, which is not very common, is fullerenes. It has got 60 carbon atoms in it. It has got the shape of a football with 20 hexagons and 12 pentagons. The structure is similar to the geodesic dome designed by a US architect, Buckminster Fuller. So it is named after him, fullerenes, earth. And apart from this, there are different forms of carbon like carbon black, charcoal, coke, etc. These are all different forms of graphite or fullerenes in impure form. The next chart will be showing you the properties of diamonds and graphite. Hope you understood the concepts very well. If you like my videos, please like, share and subscribe to my channel, Biology My Passion. Thank you for watching.